In this video, we're going to be discussing the inverse of functions. Okay, just basic ideas only. And in the preceding videos, we'll be delving more deeper into the discussion of inverse function. Okay. So let's say we have a graph f of x, right? Right? F of x is a function of x, basically, right? Basically, the f of x is your y value, né? Is the output. F of x is the output, and the x inside the bracket is basically input. So if you want to read this, you can say, what is the y value if we input x, or f input x? Do we see it? Perfect. This is a function, and we know that a function, its points are generally given by the input coordinate, the output. You always start with the input and substitute and put the output at the end. Okay, perfect. And if the inverse of this function is also a function, just remember I said if the inverse is also a function, then we can write the inverse in this form, with a -1 there of x. And ladies and gents, don't confuse this notation with the notation of the derivative for those who have done calculus already. These are two different notations. So the notation for the derivative is f with a slanted 1, which means that the first derivative of f. This with a -1 means the inverse of f. Perfect. So the inverse of f of x is basically like this. We are basically going to switch x and y. So whatever was y becomes x, whatever was x becomes y. You just switch. If here it was 3, on the inverse, the 3 will be on the x now. Perfect. So basically, in simple terms, the function and its inverse function are reflected along line y equals to x. So we reflect them along line y equals to x. Okay, perfect. So now let's go on and discuss some more things. Okay, let's check now. Remember, I said you can use this guy only and only if this guy is there is a function. Let's check what I mean, right? Perfect. So let's check here. Let's say we have a function f of x that is 1 to 1, to 1 relation. Remember, we spoke about relation in the previous video. If you haven't seen that, please watch that video so that you can understand what I'm talking about here. So f of x, that is 1 to 1 relation. We agree that its inverse will be 1 to 1 as well. So f is going to be 1 to 1 as well, right? So which means in this case, we are going to say if the function is 1 to 1, the inverse can be represented as f as well, because the inverse is also going to be a 1 to 1. And that is the only case you are going to represent the f of x with a -1 to show its inverse. Let me show you what I mean here. Let's say f of x, that is many to 1. Many to 1. E.g., a parabola is a many to 1, right? Parabola is a many to 1 function. You agree that its inverse will be 1. Remember, inverse, you're just flipping. So 1 will be here, many will be that side. Will be 1 to many. And we agree that in our previous video, we said anything that is to many, it's not a function. Therefore, the inverse of anything, I mean many to 1, it's always going to be not a function. Not a function. Therefore, cannot be represented as f minus 1. Then you can't use this to represent the inverse of a many to 1 function. You can't, because the inverse is not a function, so you cannot use the function notation for it. You're just going to represent it with a y. I'm going to show you now what I mean, right? So let's move on. I'm going to give an example here. Let's say our f of x is this. Let's say we have f of x, which is 3x squared, right? Sharp. So let's get the inverse of this. Remember, to invert it, you are basically going to switch wherever. Remember, this guy here is y. Wherever there was y, you put x. Wherever there was x, you put y. So here I'm going to put x. So x equals to 3y to the power 2. Now, you see, where there was x, I put y. Where there was y, you put x. That is the first basic principle of inverting a function. And then after switching x and y, you always want to make y the subject of the formula. Perfect. So in this case, we're going to have both sides divided by 3. Therefore, I have y squared equals to x over 3. Then I'm going to square root both sides. Square root of y squared equals to square root of x over 3. Then here you have plus and minus. So don't forget that, right? And then you have y equals to plus minus x over 3, right? And this is the only way you can represent this inverse. You can't write s f minus 1x equals to plus minus x over 3. You can't write it in this form. Why? Because this means function. This means a function. But this guy here is not a what? It's not a function. So you say that they are not compatible. So you are just going to say what? Y equals to. You cannot use f at x, g at negative 1. I mean, you cannot use this. Let me write them down. You can't use this. You can't use this. And so on. As long as this guy with a y here is not a function, you can represent him in that form. Perfect. Remember, the parabola is basically like this, right? It's, if you check, it's many x value to 1 y value. So it's many to 1. Many to 1. And then we can see that this inverse here is going to be, remember, you are flipping x and y. So it's going to be 1 to many. And then anything to many is not a function, so cannot be represented as a function notation. And that's it about this video, ladies and gents. This was just an introduction to the amazing inverse function for grade 12. Please look out for more videos and don't forget to share and subscribe to the channel. Thank you very much for your time. Thank you. See you soon.